So let's do a review of the simple data access patterns we've seen so far and identify when they may not be sufficient for a particular problem. So far, one of our main focuses has been the idea of a list, and lists we access data based on their order. So there's some distinct notion of a first item, a second item, and so on. And we may iterate through those lists using some form of a loop. Maybe it uses an actual iterator object. Maybe it uses an index to iterate through things. Or we can access things by their index specifically. In any event, things are in a particular order. The main way we work with them is somehow related to that order. We've also looked at stacks and queues, and stacks and queues allow access somehow based on the time when things are added. So when a piece of data is added to the collection, either by a push on a stack or an in queue in a queue. So if you remember, the stack was last in, first out. So the last thing to be added is the first thing to come out. So again, we're processing data kind of based on when it was added. The last thing added is the first thing removed. And a queue was first in, first out. The first thing added is the first removed. So let's identify a new problem where maybe this isn't sufficient. Okay, let's look at a problem that our existing data structures may not be very well suited for. So we'll consider an emergency room visit. Imagine that there are two people that are going to arrive at an emergency room in ambulances. The ER is staffed by just one doctor. So let's consider these two cases. Person A arrives at 1:04. On the ride over, they were diagnosed to have a somewhat minor cut. They're going to need some stitches, which will take about 30 minutes, but there's really no immediate danger to their life. Person B arrives at 1:06, so just a tiny bit later, and it was identified that they're probably suffering from a heart attack, and there's a very high risk of imminent death. So our question is, who should be treated first? With the data structures we've got so far, this might seem like a queue problem, where it's first come, first serve. Using that algorithm, person A would be the first to be treated. Don't be a monster. Prioritize. It seems like in this case, the risk to person B is so much greater than the risk to person A that it would be much more appropriate to treat person B first. Okay, so this highlights one of the limitations of our existing data structures. We're not always interested in processing data just based on its order or just the order that was added to our collection, like with a queue. So this will bring us to our new data structure, a priority queue. By the way, typically in my slides, I cite the sources of the artwork I use. Most of the time, my artwork comes from openclipart.org. When I was searching for pictures of hospital, I also searched for pictures of doctors, and I found this funny picture of a giraffe that's a surgeon and a penguin that's a surgeon. Hospitals use the concept of triage to assign degrees of urgency to patients as they arrive. So the end goal is to maximize the overall impact to patients and minimize the seriousness of the incoming casualties. I also want to look at an example of prioritization that comes from computing. So when multiple programs are running, some may be prioritized. So as an example, in older versions of Windows, it was pretty common and pretty easy to run several programs simultaneously. And in fact, so many that the CPU couldn't actually simultaneously run all of them. So some decisions had to be made about which ones would be given the most time with the CPU and which ones would be given less time. So as an example, imagine someone was working with a really large spreadsheet and it was recomputing all of the formulas. And maybe on a really slow computer, this would take a long time, maybe take 5 or 10 minutes. And the person sitting there at the computer may get bored in the meantime and fire up their favorite game. So maybe they start up a game. It was pretty common for some older versions of Windows to sometimes prioritize the thing that was most noticeable to the user. So in this case, the user interface, the window, the particular game that they're playing is the part that's most immediately apparent to the user. So the version of Windows may prioritize that and give it slightly more time with the CPU than the spreadsheet. Maybe this makes computing the spreadsheet take a little bit longer, but from the user's point of view, the part that they're directly interacting with seems responsive. So This may seem like a compromise on the amount of computing or the focus of computing, but from the user's point of view, it was often more satisfactory.